Mr. Raghavendra Mirji. He is a visionary leader and instrumental in scaling up the T&D business of Godrej. He has been associated with Godrej Group for last 2.5 decades and worked in different businesses and functions. He is an engineer holding a master's degree in business administration. Presently, he is positioned as Senior Vice President and Business Head for Electricals and Electronic Division at Godrej Boyce Manufacturing Company Limited. Mr. Mirji will discuss combining the power grid to renewable energy. So delegates, let's welcome Mr. Raghavendra Mirji.
Yeah, Mr. Shirish has given insights on the global renewable energy statistics, the need, and he also brought in the element of climate change, how it is actually triggering the increased usage of the renewable sources. And more importantly, he also mentioned, which I also emphasize more, especially from the India's point of view, is energy independence. Rather, I call energy security. So with so much of import happening on the oil and we are depleting the natural resource of coal, along with the climate issues and the net zero that we are talking, carbon net zero that we are talking about. It also economical sense for us also to, dump these fossil fuels to the best of our ability and focus on the renewable energy. Having said how the renewable energy growth has happened over the years in India. Yes, Mr. Shirish has given the story right from 1970s, but then I'm bringing just the latest part of the last 7 years. Yes, slowly but steadily, India has accumulated a good amount of capacity. And as on last month, we are at about 119 gigawatt of renewable energy. This I am not including the hydro. So if I have to include hydro, and this will be somewhere about 166 gigawatt. So very close to the target of 175 by 2022. Maybe a year back, it was looking, that an impossible task. But last 2 years, really this has scaled up. Even the percentage share of solar alone jumping significantly to almost about 37% today. But however, our large portion of power still remains the fossil fuel triggered power generations, that is thermal. Just to re-emphasize on the importance of the renewables, and just brought in the concept of the sources, from the replenishment time point of view. Solar, we are taking direct. So that's the reason this is very, very attractive. We need not have to worry about it. Wind might take few hours and maybe days depending on the climate. And when it comes to hydro, seasonality comes in. So the rainy seasons where we can accumulate more water and then can utilize. So it takes about weeks or months. Biomass, yes, it takes time for composition, and then takes maybe months and years sometimes. And however, oil and whether it is even the coal, it takes millions of years to re-establish. So very clearly giving the thrust that the solar and wind are the highly placed resources for us to really look at it. I'm just bringing a network. This is from the complete generation to the distribution. Generation, transmission, and distribution, how the today's network, the transmission network or the distribution network is done. So there is a generation, and now earlier it used to be only one source, that is thermal or maybe coal or oil or maybe the large hydel. But now we are adding the solar through large solar farms also, and we are adding a wind also, so that is getting integrated at the grids. And that there is a transmission system, and there is a distribution system where at the distribution voltage level the storage happens, and then we have a very complicated distribution network. So Mr. Shirish also brought in a point that there is a two-way exchange that is happening today, unlike the earlier days where the individuals were only receivers. Today they also can be a mini generating station. So if you see, apart from the industry, the commercial aspects, the residential aspects, who are the consumers, but there could be a great amount of rooftops, both on the commercial segments as well as on the housing. So they also will feed back the power generated through the rooftop solars to the network. There is a wind farms which will also, connect their power generated things to the network. Then there are also microgrids, which are actually operating separately, who do not really take the transmission network, but then they have their own network. So, and we are one more adding the electrical vehicles, which also requires a charging. And then this is actually becoming a very complex network to handle. Grid integration needs to be seen from the perspective. So how our grids are actually designed, in olden days, or maybe the one that exists today. It's a very old design which really takes care of producing and consuming of a conventional power. Now, as I said, I just made an yesterday and the today or a tomorrow situation. So when it comes to generation or a production, it used to be a large power plant and located at one area. So we were moving closer to the resources where the resources were available. Now you see all the thermal plants located at Jharkhand, UP, and those areas. But the consumption may be happening in west, consumption may be happening in south. So the entire network was designed keeping these things in mind. Whereas today, it will be, the need is more of a small power generation, and that needs to be that is done because to strengthen the local demand management. So the wind powers are there everywhere, the solar power are there everywhere, though they are still in few states, but definitely it is now distributed. So it is not one large concentrated generating stations and networks versus now it's a distributed generating station or a small generating station across. Then comes to the network itself, the grid itself. It is centralized, and the mostly it's a national grid. Yes, the Raichur Solapur integration has done wonderfully, to integrate the entire nation, to fulfill one grid, one nation kind of a thing. But that's how the design was done. It's one large centralized network. So if you see the bigger circle here is the generating hub, where there are the networks are done through that. However, the market today, or it is expectation, or maybe through this renewable resources, it is decentralized. So ignoring boundaries, you need not have to really design entire thing into a centralized situation. You can have very independent networks. So that's what the renewable structure comes in picture. Another thing is the grid is based on, again, the large power. So we need to have, thermal power stations having 500 megawatt, 1000 megawatt, 2000 megawatt, and hence the transmission lines also having 765 kV lines and more 400 kV lines. The substations designed based on that. So versus now, the requirements are actually narrowed down. So it includes small scale transmission systems, and the regional supply compensation is what is required today. Now, the next is both combined when I say, so receiving as well as generating, the point that I've said. So today the consumer also can be producers, and there also can be receivers. So that's a very complex situation will arrive or is arising because of the integration of the renewable energy resources, multiple resources, and hence the entire way to look at the grid design or the grid integration changes. Now I'm talking about, when we say then we need to integrate the entire renewable resources, and what are the objectives. So incorporation definitely will be, serving the distributed generation, energy storage, thermally activated technologies, demand response, electric distribution and transmission system needs to be managed well. So some of the objectives we will have to spell out very clearly. One is, yes, integration is very important from the demand side management point of view. So yes, I will come to the point, what challenges that we are facing, why we are not able to do a proper demand management side, but that's an objective right now. So if we have to integrate these things, the demand side management has to be very well handled. Then the power quality. Yes, we saw harmonics point, which Mr. Shishir made. I'll be also explaining down the line what are the quality of the power means. Yes, with the integration of renewable resources, the quality of power is impacting, especially the reactive power control becoming a challenge. So that becomes a big issue. Of course, the larger cause of reducing the carbon emissions through integration of the RE resources. And another thing is a very important factor. I just mentioned it reduce the peak load and thus lower the cost of electricity. So I would like to emphasize that the traditional systems are designed to cater to the peak load. I cannot design, entire electrical system taking care of a smaller or intermediate power loads. So I need to calculate what is your peak load. So the entire system has to be actually designed to the peak load. So, and of course, if the peak load calculation goes up, that means the cost of the entire system also goes up. Now here I'm stating that with the integration, with the RE integration, the peak load will come down, because see, many users today are also the producers, as I said. So probably in the peak period, their utilization from the main grid will drastically come down, because they will be using the solar or the wind load connected to them. We have so many PPA agreements actually coming up. So ultimately this will impact the peak load, and the peak load will come down, and hence the optimum utilization of the entire grid assets can be exercised. So that is also an object. Now it will also support the portfolio of a government, their target of 500 megawatt by 2030. This also needs to be realized, and hence the integration becomes a very important aspect. Another thing is to enhance the reliability, security, and resilience of the grid system. Now we are talking about it is connected to the previous point of the designing the entire system to the peak load. Now we have one big system of a large capacity. Now imagine something going wrong in the system. The redundancy is to an extent possible, but the entire system comes down, and then we'll have a blackout. But then microgrids coming into picture, especially in the light of integrating these renewable resources, so will be a great help in terms of exercising this reliability, because then you can mention the islanding and many things where you can avoid the blackout situation. You can manage the network more efficiently. So that is also an objective. Of course, the larger cause also will be to support reduction of the fossil fuels, especially when the EV thing that we are talking about, great reduction in terms of petrol, diesel, that also helps. So these are the key objectives why the RE integration becomes very, very important. Now let us talk about challenges. So integration is fine. We all understood the importance. We understood all those things. Then what are the challenges? Yes, some of the aspects, again, it's a repetition, what Mr. Shishar was already brought in. So balancing grid stability is a key challenge. So especially because you see the nature of the generation of any renewable resources, be it wind, be it the solar, we have the vulnerability in terms of variation. So solar has its own thing. In the daytime it will be there, in the nighttime it is not there. In rainy season it won't be there much, in cloudy season it may not. So in the sunny days, yes, we get a better thing. Similarly for the wind, in the wind you can have even a quick changes. So half an hour back there will be a great wind and the generation is different. Half an hour later the wind speed comes down and the generation impacting the entire system. So this variation is causing a great impact on the entire stability of the grid to be managed. To be precise, because of the variation of these resources, it is very difficult to balance the demand or maybe from the supply side, because the other side, the corrective action needs to be taken is from the thermal plants or maybe from the oil plant. So changing a quick or making a quick changes to adjust this load for the conventional power is actually not a easy thing, and it will decrease the efficiency of those plants also. So hence balancing a grid stability becomes very, very difficult. We talked about ramping. Yes, I can bring some statistics there. So the present ramp rate is 200 megawatt per minute in the evenings, and then about 140 megawatt per minute in the morning. Now from 140 to 200, ramping up such a variation is not a simple thing, and we do lack a mechanism to compensate such variation in a quick session. So that is also causing a lot of issues in the grid. As I talked about, the quality of the power and mainly the reactive power management, because of the long lines that the evacuation is happening. We talked about RE corridors and solar parks. So the large volume is evacuated through a long lines is actually creating a lot of reactive power, and there is a limitation in which how this needs to be managed. And also because of the variation in the line loading. So we may design a 765 kV line or maybe 400 kV line, but the renewable resources are not steady enough to to handle the load in those lines, that variation also is giving a huge impact on the quality of the power. Somewhere even in the solar, the inverter sensitivity is also very important for the voltage variation, which also causes quality issues in the quality power that we take. Yes, the power quality becomes a major challenge to maintain for such integrations. Of course, another big challenge is how do we really handle the scheduling and the forecasting. And the 2 points that I talked about in the first, balancing variation and the ramping, is actually becoming a big issue to the any SLDC to manage the forecasting and balance and ensuring the demand side is fulfilled. So quick variation and small windows I talked about for the wind power. The large forecasting error may be because of the rainy seasons. We don't know, it's such an uncertainty how things can happen, and suddenly how the power situation changes for these renewables. So it is very, very difficult to implement a very secure and uninterrupted power, for the SLDC to manage all this issue. So these are the big challenges. Yes, there are solutions. So technological solutions have emerged in a big way, to ensure the smooth transition of renewable resources to the grid. So the first thing is energy storage. Yes, the battery technology has changed a lot. Different material is being experimented to increase the efficiencies and reduce the cost. So the peak period power can be stored through an energy storage devices and can be utilized during the nights. And we have seen now the hybrid projects being tendered even in Gujarat. So keeping both solar, wind and the storage as a combined solution. So that will really help resolve the stability issue or a variation issue in a big way. We will also use a different RE sources, as I talked about. Rather than depending only a solar park and then end up having the issues of day-night issue, or having only a wind power, having issues on the the speed of the wind or the seasonality. Now I have a different RE resources. I have biomass also, I have wind power also, so I have solar also, and I talked about energy storage device also. Such a combination will also really serve a lot of purpose. Resolve a lot of issues that I talked about. Now, on addressing the quality of power quality that I talked about, today's modern power quality management systems are well equipped in terms of having a technologies like voltage flickering, unbalanced phase voltages, and harmonic distorted or contaminated supply. These are the issues. The technologies like VR compensators, active filters, surge suppressors, automatic power factor controllers, transient controllers, etc. are there to address these issues that I talked about. And to a large extent, the power quality is now really managed. On the outage management system, I talked about scheduling, forecasting becoming an issue. So increased use of the SCADA, so connecting entire grids together and then establishing a communication, and automatic metering instruments also giving a stability in terms of the demand, accurately assessing the demand. So we are talking about remote terminal unit also, and the phasor measurement units, etc. These are the technological evolution that is actually helping the SLDCs to equip better in terms of addressing the demand side and forecasting side issues, even after incorporating all the different renewable resources to the grid. As I mentioned, microgrid can be a great solution. So implementing microgrid can really help in reducing the peak loads, in isolating the redundancy issues and other things. So this will also address the issues that we are facing. Some of the government initiatives, yes, REMC, Mr. Sheshari talked about. I will not reiterate on that. Green energy corridors is also separating the entire requirement, and integrating this through a separate lines and grids is also a great idea, where a lot of initiatives have come up from the government side in initiating the green energy corridors. Battery storage, as I mentioned, a lot of push has come from the government in terms of funding for different technology, and a lot of industries have come up today even in India to manufacture the batteries. The WAM technology is another thing which is very good to address the issues. There is wide area monitoring, protection and control systems, which will give a good accurate forecasting things, and it will manage the demand side also and ensure a stability in the grid. Demand response pilots are done through the automated metering infrastructure, and this also helps in improving the forecasting and demand side for the SLDCs. So these are the government initiatives, and if I have to sum up as a conclusion, so integration of all these renewable resources to the grid is really beneficial, and it will really improve the efficiency for the generation as well as for the transit of this power to the load centers. Utilization of conventional resources can be reduced in a much better way, and it is definitely an advantage to the environment. Cost, as I said, it serves the energy security thing that I talked about. Sustainable energy is definitely is a need of the hour, and the inclusion of natural resources is a must today. So, and I really wish we are extending one grid, one nation, and now we are talking about we have added one sun. So one nation, one sun, one world, and then let's have a very smooth and efficient transition of all these renewable energies. So I'm very confident that with the technological evolutions that is continuously happening, we'll address some more issues that may still come up, and then we are very confident of really handling the renewable resources in a much better way than what we used to be earlier. Thank you very much.